Hey guys, welcome to our next session. We have Alex here, CEO of IDEX, and this session will be on IDEX 2.0, a case study on pragmatic decentralization. Can you guys confirm you can hear him? And Alex, can you say something?
Hey everyone, thanks for having me. Good to go? All right.
Good to go.
Thanks everyone for confirming. Hey everyone, thanks for coming out today. Feels a little odd to be doing a presentation virtual like this, but I mean, awesome to see the attendance, over 3,000 people. I can say the butterflies are still there, just as if I was coming out on stage in front of you. So again, thanks for taking the time to come today. Wanted to take a moment just to thank our sponsors as well as the hosts here for putting on an amazing event. I think it's a world-class set of speakers, and I'm really excited and honored to be part of this group. And I hope that I'm able to impart a little bit of knowledge to you today throughout my presentation titled A Case Study in Pragmatic Decentralization. So with that, I'll go ahead and kick it off. All right, so as I said, the title of the presentation is A Case Study in Pragmatic Decentralization. I think everyone is here because they're excited about the capabilities and the possibilities that decentralization brings. We're able to bring new types of user experience to customers. We're able to break down barriers, disintermediate third parties. It's a really powerful technology and it has a lot of possibilities. But in the process of building IDEX, we've realized that there's times that decentralization can actually be a negative impact. And so I wanted to talk through our journey of building IDEX, highlight some of the UX challenges and issues that we ran into and how we worked around them. So we're going to be talking about some of the different trade-offs we've made using our IDEX development process as a backdrop. So as I mentioned, decentralization is both fantastic, but also it comes at a cost. So decentralization is expensive in certain ways. So one example of introducing decentralization into the application is that it can introduce forms of latency. So if you think about any time that your application has to talk to the blockchain-based network or communicate, or in particular mine a transaction on the network, it's going to take some time for you to communicate between that and the decentralized computing network. Similarly, the miners are not doing this work for free. So any transaction that you make is going to incur a network cost. We currently operate on Ethereum, so that bubbles up in the form of gas costs. So you have to think about those network fees and the trade-offs that are associated with them. All this together leads to a form of UX friction. To summarize, you really need to think about where you're adding decentralization into your application and how it's benefiting customers. And our conclusion is that you should really be selective about this decentralization and only decentralize what's necessary to achieve your specific product goals. So as I mentioned, we want to talk about this in the context of our development process of building IDEX. So before jumping in, I need to tell you guys a little bit about what our specific product development goals are. So IDEX was born out of a frustration with the security issues that are presented on centralized exchanges. My co-founder was part of the Mt. Gox hack, and after which a lot of people in the community were looking at different technologies and possibilities of solving the security and custody risk that's posed by centralized exchanges. So that's really the number one goal of our product, is to have improved security by never taking custody of users' funds. That's first and foremost what we're trying to achieve with IDEX. Second, we want to allow customers to have flexible custody. So we want it to be possible for you to be able to plug in any custody solution, regardless of your preference. You know, we think users are going to be trading from private key hardware and software wallets, but all the way up to custody solutions like institutional custody providers like BitGo and Fidelity. And then lastly, we want to bring an element of transparency to the process. So centralized exchanges have a lot of critiques for things like wash trading, and we think there's an opportunity to use blockchain-based networks to bring more transparency to the operational process. Outside of these three goals, we really want to compete and be able to build a product that has the same user experience of centralized exchanges. We want, we think for the most part that users are really pleased with those product offerings. So we want to see how we can compete and build something that is on par with them from a usability perspective, but while bringing these additional positive benefits that come from incorporating decentralization. So before I can talk about the different models that we've explored and kind of our journey on this development process, I need to give a quick primer on the different components of an exchange. So I like to think of an exchange as consisting of two core functions. The first is all of the different elements that help bring buyers and sellers together. Now, I should note in this presentation, I'm talking specifically about central limit order book style exchanges. So you're probably familiar with automated market makers like Uniswap, which are a different type of exchange product that have recently come to market. What I'm discussing here is what you think of in your more traditional exchange form, where you have a central limit order book. So the ability for buyers and sellers to place orders and broadcast those to other users who can then come along at a later date and identify trades that they want to execute. So in combination with the order book, you also need a method for users to match with specific orders. So this is takers who can identify an order that they want to trade against, and then some process under which those trades are executed. Some mechanism to lock the users into the trade so that both users are legally or contractually obligated to fulfill their side of the trade. Now, what's interesting here is that in traditional finance, the exchanges perform these specific functions. They're limited to this process of bringing buyers and sellers together. However, cryptocurrency exchanges, because of the bearer asset nature of cryptocurrency, have two additional functions that have to do with actually holding and settling transactions, holding the funds on behalf of customers and settling those transactions. So this refers to custody, the act of taking control of the underlying cryptocurrency, and then the settlement process by which the assets are actually transferred from one user to another. So keep these elements in mind as we talk through the different designs, because I'm going to highlight different ways that you can decentralize certain components and some of the kind of implications of these different design decisions. So as I mentioned, my co-founder was unfortunately part of the Mt. Gox hack, one of the users. And coming out of that, he actually teamed up with a few others and started working on what was known as IDEX. This is one of the very first decentralized applications, and it's what's known as a fully on-chain DEX. So thinking back to the core components of the exchange, the first requirement, and something that you'll see is shared by all of these different designs, is that it has on-chain custody. So as I said at the beginning, our goal is to never take control of users' funds. We want to make sure that users are always able to access them and that they stay in control of the funds throughout the entire process. However, in this design, actually all of the different exchange elements were located on-chain. So this includes things like the order book. So in order for a market maker to create an order, they had to first create and sign the transaction and then submit it to the Ethereum network for mining. Only after the transaction had mined did the order appear on-chain in the on-chain order book, available for others to see and trade against. Now, the matching process was managed by the end user. The end user was responsible for identifying which order they wanted to trade against. This happens either by reading directly from the underlying blockchain or using a UI, some sort of front end to help facilitate that process. But it's ultimately up to the user to match and identify a specific order that they want to fill. Once the users identify the order that they want to take, it's then their responsibility to submit the order to the network for both execution and settlement. So what we have here is probably the most decentralized design that you can think of in terms of a decentralized exchange. All of the key architecture components are built using smart contracts and reside entirely on-chain. And the only off-chain process of matching and identifying trades doesn't require users to go through any particular UI or third party. They can actually do this process themselves by interacting entirely with the underlying network. However, because it's so decentralized, so unquote, you also have issues with latency and network costs. In particular, it's problematic for market makers who want to place and cancel orders because every time they do so, they have to submit an order to the underlying network, which incurs both a delay while waiting for transactions to mine, as well as a network cost in the form of gas. So the result was something that's extremely decentralized, but was also so expensive and slow that it wasn't really suitable for the vast majority of traders. So this was kind of late 2015. In mid 2016, we saw the launch of EtherDelta. Many people are familiar with EtherDelta. It was probably the first really runaway success decentralized application. CryptoKitties had a few weeks where it clogged up the blockchain, but EtherDelta really had many, many months of sustained usage and popularity. And like all DEXs, EtherDelta used on-chain custody to make sure that the funds were always in control of the end user. However, unlike EtherX, EtherDelta was the first to bring the order book off-chain. So market makers are still creating an order that's specifically a market maker order and submitting it to an order book. But rather than storing it on chain, rather than having to submit it to the Ethereum network, it was stored off chain in a centralized database. So this is the first example we see of kind of undecentralizing or re-centralizing some component of the exchange. However, it was in doing so, they were able to benefit the end users in two different ways. One, when submitting orders to the order book, you no longer had to worry about the delay that would occur for waiting for the transaction to mine. And two, you no longer had to pay the underlying gas costs to submit that order to the network, because until it was actually a trade, there was no interaction with the blockchain. Similarly to EtherX, the end users are responsible for identifying and matching against specific orders. And then once an order has been identified, it's still the end user's responsibility to submit the order to the network for execution and settlement. So as I mentioned, this small change of bringing the order book off-chain had a big impact because it made it much cheaper and easier for market makers to provide liquidity. EtherDelta had a lot of success, which actually in the process started to reveal some other UX issues that came from certain design decisions and certain elements of what's on and off-chain. In particular, I'm referring to what's known as on-chain trade collisions, or the potential for front running. So if you think about the process of trade submission here, the end user, the taker, is responsible for identifying an order and submitting it to the network for both execution and settlement. Now, there's a delay between when the user submits the order and when the network actually mines that transaction. In that period of time, the order itself, the maker order, is still valid and visible on the order books. At that time, anyone else is able to still submit an order for that same transaction. So you had two forms of front running, either malicious front running, where users and other applications would watch pending transactions and intentionally intercept the order out from underneath users, knowing that there's more demand for the order and they could potentially sell it back to them later. Or what we actually found was more common, this form of unintentional front running, where multiple users are competing for the same order on the books simply because it's the best price order. So because you didn't have anyone coordinating this trade submission and execution process, you opened up users to this negative feedback loop, where the more users you had on the platform, the more competition you had for the top orders, and the more likely you were to have these issues of on-chain trade collisions. We actually saw that at its peak, over 20% of transactions that were submitted to the network would fail on contract, meaning the users had submitted a trade that was valid at the time of submission, but the order was no longer available by the time that their transaction was mined. Okay, so we at IDEX, we saw these issues evolving on the EtherDelta platform, and we thought, what's a way that we can address this UX problem of on-chain trade collisions? This is where we came up with the design for the current version of IDEX, which we call a hybrid decentralized exchange. So again, just like other DEXs, custody is managed on-chain because we never want to be taking control of users' funds. The order book, just like EtherDelta, is off-chain. Market makers have to identify their order as a maker order ahead of time and submit it to be stored in our off-chain database. Users are still responsible for matching and identifying what trades that they want to trade against. However, instead of submitting them directly to the underlying network, users submit these transactions first to IDEX for off-chain execution. When an order is submitted to IDEX, IDEX essentially performs a pre-check of what the network will do. The IDEX system will check to see that users have the funds are actually custodied in the contract, and they'll make sure that the signatures of both users are valid, essentially making sure that this transaction would mine were it to be submitted to the Ethereum network. If all of those checks pass, then we update the balances of the user off-chain and immediately pull the order from the order books. So in doing so, we're able to prevent other users from potentially trying to trade against that same order. Now, behind the scenes, we then submit that order to the network for settlement. Now, so this is another example of where we removed elements of decentralization. In this case, IDEX is the only one that's able to submit trades to the network for settlement. You no longer have that more open system where any user is able to match and submit a trade by themselves. However, by doing so, we're able to coordinate that trade execution process, eliminate these on-chain trade collisions, because we can guarantee that when users see orders on the order book, that there's no pending transaction out there waiting to be settled. So we're able to eliminate those on-chain trade failures. And you can actually see that if you look at the IDEX contract on network or something like Etherscan, you won't see the same trade failures that you would see on EtherDelta. So we thought we had success, right? We had identified multiple UX issues in terms of cost, frustrating failures, things that would annoy customers. But again, actually, this just uncovered yet another set of potential issues, this time in the form of what we call off-chain trade collisions. So if you think about the process, if you've ever used any sort of dApp or decentralized application, in particular with something like MetaMask or Ledger, there's kind of a multi-step process. You first have to, within the application, identify the action that you want to take. In this case, users saying, I want to trade against a specific order. But then you also have to authorize and approve that trade with your wallet, whether that be the pop-up in MetaMask or signing the pop-up that happens on your Ledger hardware wallet. This is another form of latency that's introduced into the user experience. It's not on-chain, but it still is a delay between the user indicates their intention to fill an order and when they've actually signed and approved it, and that we, the exchange, can guarantee that the order will settle. And so what we found was that it's very frequent where users have agreed to a trade, yet it takes enough time for them to approve it that someone else swoops in and takes that order out from underneath them. Again, this isn't malicious. This is just multiple users competing for the same order on the order book. So we now had real-time trading, but had uncovered yet another potential UX problem in the form of off-chain trading collisions. So we started to see this in mid-2018, and we again went back to the drawing board and started to think about how can we address this kind of once and for all and build a system that really has that user experience and performance of a centralized exchange, but those elements of decentralization that we're trying to bring to our customers. And this is where we are today with IDEX 2.0. So IDEX 2.0 is something that we've called high performance non-custodial. We've been working on it for a little over a year, and we're going to be bringing it to market in about a month, end of May or early June. Again, like all non-custodial exchanges, custody is on-chain within the smart contracts. The order books are off-chain. However, there's a unique change in terms of how orders are created. Users no longer have to specify upfront whether or not they're creating a maker order or taking an existing order that's already on the books. So all users will submit the same type of order to the exchange, and then it's the exchange's responsibility for matching and executing trades against orders that overlap. So this is, again, another example. In this change, we've removed the ability for users to choose which specific order they want to trade against. We now have a centralized matching and execution process that helps route users into the appropriate overlapping orders. So in the example I gave where a user has a delay in signing due to MetaMask or Ledger, if the underlying transaction that they wanted to trade against, if that order is taken by someone else, then the exchange has the ability to rematch them into an equivalent order, or if no such order exists, to place it on the order books as a new resting limit order for someone else to match against in the future. Once those trades have been matched and executed against, we're then able to send them to the underlying network for settlement. So a few key things here. By introducing a proper matching engine, we're now able to process hundreds of thousands of orders per second. So this will allow us to actually match the performance and throughput of centralized exchanges. It also gives us the ability to incorporate other different order types that wouldn't be possible if you didn't have central coordination of the matching and execution process. Lastly, we're pairing this with a new layer 2 design that will ensure that as our off-chain activity grows and scales, we're able to settle all of these transactions in a much more affordable manner. And so it's funny because in some ways we look at this as really a centralized exchange. It's no longer a DEX. If you look at the different components here, all of the exchange functionality is off-chain. And we're really just using the underlying network for custody and settlement to solve those issues that I highlighted at the beginning. And I think it helps to kind of draw back to those core parts of an exchange in the framing of traditional finance versus versus centralized exchanges. So in traditional finance, again, they're just responsible for the exchange components of helping buyers and sellers find each other. And that's essentially what we're now doing with IDEX 2.0. We host the order book, we have the matching engine, and we execute trades based on overlapping trades between users. We're then using the network, the underlying smart contracts, to handle custody and settlement so that we can now deliver the centralized exchange experience that we want with those additional IDEX product goals of security, flexible custody, and transparency. Okay, so that's the end of my prepared remarks. Hope you found it was interesting. I'll go ahead and bring video back and let me know if you what questions I can answer. All right, let's see. Top question, is IDEX still planning on creating its own stablecoin? I'd say yes, we have intentions longer term to do that. However, we think we have some unique opportunities here with what we've built with IDEX 2.0. So most of our efforts are focused on that in the short term. Cost of maintenance for a local global DEX project. I guess I don't quite understand the question. I guess maybe one thing that's interesting is, a lot of the challenges of centralized exchanges is having to deal with custody, either just the cost and risk of holding funds or managing hot wallets, withdrawal systems, et cetera. So if you're able to nail it in terms of having the underlying network manage that functionality, then you're able to reduce the cost of servicing customers. So what are the order types that require central coordination? So for example, something like a stop loss. So if you want to have the ability for an order to execute when the market moves past a certain price point, some entity or system needs to be available in order to execute that order at the right time. So it's possible for users to build those systems themselves that watch a decentralized exchange order book and wait for prices to move a certain level before executing those orders. But it's much, much easier for the vast majority of users to have an exchange matching engine identify when the order prices have moved a certain direction and make those order submissions. Yeah, so question around IDEX 2. Do users submit a price parameter with their orders? Where'd it go? If not, are all orders effectively considered marketable limit orders? Yeah, so to dig into that a little further, so most of the DEX designs today use this, and I touched on it a little bit, this concept of a maker-taker order schema. So the market maker order is different than what takers are submitting at the contract level. So the maker order identifies the assets as well as the amounts. The ratio of those amounts determines the price of the trade. When a taker submits an order, they're just including a hash of the maker order and identifying a certain amount of the trade that they want to take from that maker. But you'll notice if the taker were to submit that to a matching engine, we wouldn't be able to match that with another order because there's no information about what trade they're trying to do. So in IDEX 2.0, trades are no longer upfront designated as maker or taker. Users just submit a transaction that is kind of a true limit order. It's got the parameters of which assets they want to trade, the amounts and price of those assets. And then the exchange is able to match and execute trades that overlap. So similar to other decentralized exchange designs, we can't match you with something that doesn't meet your criteria. So you still have the guarantee that users are signing and approving those transactions. It's just a more efficient way of doing so to eliminate some of those UX issues I highlighted. Could you use a layer 2 solution to make the off-chain computation on-chain? I'm not sure exactly what the question is getting at. I think a lot of the benefit of layer 2, it comes from bringing computation off-chain. So just to touch on that a little bit, a lot of people are excited about different roll-up technologies. Our design is a form of a roll-up in the sense that we execute transactions off-chain and then submit proof of those transactions to the layer 1 using a Merkle root. This is a similar design to things like optimistic roll-up or zero-knowledge roll-up. The question then becomes, how do you prove to the underlying network that that Merkle root summary was legitimate? And we have some unique approaches to do so. Best to probably check out our blog information where we have a lot more detail on that. But kind of the core way that you scale using layer 2 is by not doing all the computation on chain, but rather doing it off chain and submitting proof of that activity to the layer 1. Yeah, what kind of regulatory burden does the new design place upon IDEX 2.0 and upon the customers? So this is a really interesting question. I think you'll see teams interpret this differently. Our opinion is that all smart contract-based applications, most DeFi applications, are required to comply with KYC AML guidance, in particular from FinCEN here in the US. Their recent guidance made it clear that they don't view the use of smart contracts as something that make those applications exempt. Now, there's a different question of, kind of enforceability around those. I mentioned the fully on-chain versions. They just live on the Ethereum network. So if it's out there, it's decentralized. It's kind of like Bitcoin or Ethereum itself. In our case, we have a lot of off-chain components, even in the current version, in terms of this execution. We have an off-chain layer 2 execution system. All that's to say that we don't think our compliance burdens are very different from that of centralized exchanges.
All right, Alex, let's take one last question.
Okay. Let's see. All right, last one. So is IDEX still building on Algorand in 2020? Yep. So we're excited about the possibilities of new blockchains. We've been focused on, as you can see, a lot of effort went into the new version. So we've been focused on building on our Ethereum version, but we're going to be expanding it to a lot of different layer 1s going forward. Algorand is the first one we plan to expand to here in 2020.
Awesome. Thanks so much for the really great session. We're going to transition to our next talk. Feel free to reach out to Alex on Twitter if you have any questions.
Cool. Yeah. Thanks, everyone. Really appreciate the time.